Last time, we talked about how the James Webb Space Telescope is finding these unbelievably massive black holes in the super-early universe, way bigger than they should be. It's like finding a fully grown redwood tree where you only expected to see a tiny sprout. This completely messes with our established timelines for how galaxies and their central black holes grow up together. Today, we're diving deeper into the chaos. What exactly does this mean for our understanding of the cosmos? Are our favorite theories about galaxy evolution completely wrong? Let's get into it. The standard picture, the one we've been working with for decades, is a story of co-evolution. A baby galaxy forms, and at its heart, a small seed black hole appears. This seed could come from the collapse of a massive first-generation star. Over billions of years, this seed black hole gradually feeds on the gas and dust swirling around it. It also merges with other black holes when its host galaxy collides with another. It's a slow, steady process. The galaxy grows, the black hole grows. They're like dance partners, each influencing the other's moves in a cosmic ballet that spans eons. We see this relationship everywhere in the modern universe. There's a well-established correlation between the mass of a galaxy's central bulge and the mass of its supermassive black hole. It's a beautiful, elegant theory. And JWST might just be tearing it to shreds. The black holes JWST is spotting are not just a little overweight. They are monstrous. We're talking about black holes that contain a significant fraction, sometimes even up to 10%, of the total mass of their entire host galaxy. In our own Milky Way, the supermassive black hole Sagittarius A is a mere fraction of a percent of the galaxy's total mass. So these early universe discoveries are completely out of whack with what we see today. They're overmassive, as astronomers are calling them. This isn't just a minor anomaly, it's a fundamental contradiction. If the galaxy and black hole are supposed to grow together, how did these black holes get so huge, so fast, while their host galaxies were still just tiny toddlers? This leaves us with two mind-bending possibilities. Possibility 1. Black holes grow way faster than we ever imagined. The standard model of accretion, where gas trickles down onto the black hole, might not be the whole story. Perhaps in the dense, chaotic environment of the early universe, there were mechanisms for super-efficient, rapid feeding. Some scientists are proposing ideas like hyper-Eddington accretion, where black holes gorge themselves on gas at a rate that was previously thought to be physically impossible. Imagine a fire hose of cosmic gas being funneled directly into the black hole, bypassing the usual traffic jams of an accretion disk. This would allow them to bulk up incredibly quickly, far outpacing the growth of their host galaxy. But then there's possibility 2, which is even more radical. What if the black holes came first? Instead of a galaxy forming and then seeding a black hole, what if a massive black hole formed first and then acted as the gravitational seed around which the galaxy itself began to form? This is the black hole first, or primordial black hole model. In this scenario, you don't start with a small seed from a collapsed star. You start with a heavy seed, a massive black hole, that formed directly from the collapse of a gigantic cloud of primordial gas in the very early universe. We're talking about black holes born with a starting mass tens of thousands or even hundreds of thousands of times that of our Sun. This concept completely flips the script. The black hole isn't a consequence of the galaxy. The galaxy is a consequence of the black hole. This massive central object would act as a gravitational anchor, pulling in gas, dust, and dark matter, effectively building its own galaxy from scratch. This would elegantly explain why we're seeing such massive black holes in relatively small young galaxies. The galaxy just hasn't had enough time to catch up to the pre-existing behemoth at its center. This is a huge paradigm shift. It changes our entire perspective on where we came from. We thought galaxies were the fundamental building blocks, but maybe it's been about the black holes all along. So, how do we figure out which of these wild ideas, if any, is correct? This is where the power of JWST truly shines. It's not just finding these objects, it's allowing us to study them in unprecedented detail. By analyzing the light from the host galaxies, astronomers can measure how fast stars are forming. If the black holes are growing through hyperaccretion, we might expect this process to have a dramatic effect on the surrounding galaxy, either by blowing gas away and shutting down star formation, or by compressing gas and triggering bursts of it. JWST can also look for evidence of heavy seeds. If these primordial black holes were common, we might be able to spot them directly or see their gravitational influence on the surrounding matter even before a large galaxy has formed around them. Scientists are now designing specific observation programs for JWST to hunt for these very signatures. They're looking for incredibly red, distant objects that might be the quasars powered by these direct collapse black holes, or searching for the gravitational lensing effects that these isolated massive objects would produce. Every new image, every new spectrum from JWST is a clue in this cosmic detective story. What's so exciting is that we're living through this scientific revolution in real time. These aren't just abstract theories, they are testable hypotheses. The data is flowing in, and the models are being frantically updated. It's a messy, chaotic, and thrilling time to be an astronomer. The universe is showing us that it's far more strange and creative than we ever gave it credit for. Our neat and tidy story of coevolution might be a special case, a description of how things work now, but not how they began. The early universe was a different place, with different rules, and the James Webb Space Telescope is our time machine, allowing us to witness that epoch for the first time. The discovery of these overmassive black holes isn't the end of a theory. It's the beginning of a whole new chapter in our quest to understand our cosmic origins. It forces us to ask bigger, bolder questions. Were black holes the architects of the cosmos? Did the giants that lurk in the center of every galaxy, including our own, come first, sculpting the starry homes we see today? But for the first time, we have the tools to find them. Thanks so much for joining me on this deep dive into the cosmic unknown. It's a wild ride, and we're just getting started. If you enjoyed this, make sure to like, subscribe, and hit that notification bell so you don't miss our next exploration. What do you think came first, the galaxy or the black hole? Let me know your thoughts in the comments below. See you next time.